Hello everyone, I'm Sandhya Christie, Assistant Professor ECE, and today's topic is Embedded Systems. Now let's see what is an embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within a larger systems. These systems can be programmable or have a fixed functionality. While embedded systems are computing systems, they can range from having no user interface, for example, on devices designed to perform a single task, to complex graphical user interfaces such as mobile devices. User interfaces can include buttons, LEDs, that is light emitting diodes, and touchscreen sensing. Some systems use remote user interface as well. In the given block diagram, we can see embedded computer has both hardware and software, input variables and output variables, user interface, and link to other systems. Few examples of embedded systems are automobiles, mobile phones, industrial machines, medical equipment. Let's see about embedded systems hardware. An embedded system architecture of an embedded system is centered around its microcontroller, also sometimes referred to as the microcontroller unit MCU, as shown in the block diagram. Typically, a single integrated circuit containing the processor, RAM, flash memory, serial receivers and transmitters, and also other components as given. An embedded system uses a hardware platform to perform the operation. Generally, an embedded system comprises of the following: power supply, memory processor, timers, input-output circuits, serial communication ports, and SAC, System Application Specific Circuit. Let's see what is embedded system software. Embedded software is used to control the limited set functions of hardware devices and doesn't generally need input. It is not typically worked with directly by users. Its functions are activated by external controls, either external actions of the device itself or remote input. An embedded system software is intended to keep in the view of the following three limits. Those are the convenience of the system memory, convenience of processor speed. When the embedded system runs constantly, there is a necessity to limit power dissipation for actions like run, stop, and wake up. Embedded system software development tools are mentioned: MPLAB, Arduino software, PSpice, MATLAB, Proteus, Visual Studio, LabVIEW, Keil, etc. as given. The next one is characteristics of embedded system. The functionality of no two embedded system applications is bound to be the same. The functionality of a washing machine is different from that of a microwave. However, the functionality of a laptop and a desktop are almost the same. It doesn't mean live operation. It means the software programs hardwares to operate in a time-bound fashion. It couldn't also have two modes, hard and soft. The former mode indicates that task has to be completed within the allotted time, but in the soft mode, the system could be used additional time over the allotted time, example microwave. As an embedded system design aims for any particular application, it involves less manufacturing cost as compared to a versatile general computing system. As a result, embedded systems also require less power to perform operations. Depending on the type of processor and memory requirements anyway vary. For instance, small embedded systems would require less memory, but sophisticated systems demand more memory and run on multi-core processors. There are many design constraints to consider around the cost, performance, size, and power of an embedded system to realize its absolute performance. These design factors are kept to a minimum to justify their simple functions. Classification of embedded systems. Embedded systems are classified based on two factors. That is, the first one is performance and functional requirements. The second one is performance of microcontrollers. Performance and functional requirements. Real-time embedded systems. Real-time systems are those systems that work within strict time constraints and provide a worst-case time estimate for the critical situations. Embedded systems provide a specific function in a much larger system. When there is an embedded component in a real-time system, it is known as real-time embedded system. Further, this real-time embedded system is divided into two types, that is soft real-time embedded system and hard real-time embedded system. Soft real-time embedded system. These are embedded real-time systems which are used to perform soft real-time tasks. These are simple design systems and there are chances of inaccuracy. Next is hard real-time embedded systems. These are embedded real-time systems which are used to perform hard real-time tasks. These systems are designed in a very complicated way. These are accurate systems. Few examples of hard real-time embedded systems are traffic control system, military usage in defense sector, and medical usage in health sector. Second one is standalone embedded system. This type of embedded software, as the name suggests, can work by itself without requiring a host like a computer or a processor. It simply takes input data in its digital or analog form and delivers an output that might be displayed through a connected device. Few examples of standalone embedded systems are MP3 players, microwave ovens, and calculators, etc. Third one is networked embedded systems. Networked embedded systems are a collection of processing nodes which are spatially distributed and have varied functionality. They are interconnected by means of wired or wireless media and associated communication protocols. Few examples of networked embedded systems are home security systems, ATM machine, and card swipe machine. Fourth one is mobile embedded system. Mobile embedded systems are small size systems that are designed to be portable. Digital cameras are an example of this. Networked embedded systems are connected to a network to provide output to other systems. Examples include how security systems and point of sale POS systems. Few examples of mobile embedded systems are MP3 player, mobile phones, and digital camera, etc. Next classification is performance of microcontrollers. Small scale embedded system. Small scale embedded systems are entry-level systems in which 8-bit or 16-bit processor is used. For the development of small scale embedded system, we need an integrated development environment, that is IDE, for writing the code. Second one is medium scale embedded systems. Medium scale embedded systems are designed using an 16-bit or 32-bit microcontroller. These medium scale embedded systems are faster than that of small scale embedded system. Integration of hardware and software is complex in these systems. An ATM might be one of these. Sophisticated embedded systems which are highly advanced, boasting multiple 32 or 62-bit microcontrollers. Examples of medium-scale embedded systems include MRI machines and safety critical systems. Hope you have a very clear and brief explanation regarding embedded systems. Thank you.